All right. Hopefully, things won't be as chaotic as the last hour. So, things were a little chaotic in this room last hour. 2 doors down, somebody decided to projectile vomit during homeroom. So dealing with that. Then the student had a medical incident in the flang during class, and then the internet went down during class. So hopefully everything works this time. I do want to get through 3 things today. Okay, so thing number 1 is got some notes to do. Thing number 2 is I want to hand back some tests and some quizzes. And thing number 3 is I want to talk to you about your formatives. Well, we did formatives last week Friday, so I want to talk to you about those. So those are the 3 things that I would like to do. Just a couple of reminders before we start. Happy National Tortilla Chip Day. There wasn't much to choose from today. There was only 2 days to choose from today. It was either National Tortilla Chip Day, which I chose, or it was National Trading Card Day. So I went with tortilla chips because chips and salsa, thebomb.com/org. Okay? Other reminder, you will have a test next week, Tuesday. That test will include navigation and vectors. Okay? So that's what that test is going to be on next week, Tuesday. Okay? Another reminder too, Pi Day extra credit. That member is bringing in a pie for some extra credit on Pi Day, which will be the 13th, which is 1, 2, 3 weeks. So you got 3 weeks to plan your pie. Yep. All right. Any questions on anything of that sort? Okay, let's jump into it. So I do have a warm-up problem for you today. A soccer ball is acted upon by 2 forces. Just as a side note too, I see most of you went and grabbed them. I will be showing you how to do all of these calculations on the Inspires. So if you wanted to get more proficient with that, make sure you go and grab one. But again, you don't have to do it on the Inspire if you don't want to. All right, so I'm going to go force A. Oops, that's a bad, let's say a backwards 7. Force A is 314 newtons, so that's its magnitude at a direction of 45 degrees. Force B would be 272 at a direction of 135 degrees. So on my calculator, I'm going to go 314 cosines of 45, and I'm going to store that as my A. So that's going to be the horizontal component of my first vector. Then I'm going to go 314 sines of 45, and that's going to be my vertical component of it, 222,032. Then I need to calculate 272 cosine of 135 degrees, and that's going to be my horizontal component of my second vector, and then 272 sines of 135 degrees is going to be my vertical component of my second vector, 192, 333. My resultant vector then is going to be the vector A plus the vector B, which is going to be just those horizontals added up and those verticals added up. On the calculator, I went A and H. I'm going to store that as my X. I went B and I. I'm going to store that as my Y. 296985. And 414365. Okay. The magnitude is going to be the magnitude of AB. The direction, we want to find the direction of AB. So we're switching now here to just AB, or excuse me, A plus B. So next off, we can find the magnitude of A plus B. So that's going to be 29.6985 squared plus 414.365 squared. Take the square root of that. On my calculator, it's even easier because I just do the square root of x squared plus y squared. And so the magnitude is going to be 415.42749. 415. Seven four nine. 2749. Okay. All right. And then the A plus B is in quadrant number 1, so I can go right to A plus B's direction angle. Don't have to use reference angles because it is in quadrant number 1. Here then, inverse tangent of y divided by x. 85.9005. So the result would be 415.427 newtons was the force, and that's going to be at an angle of 85.901 degrees would be the resultant bearing and magnitude. Questions on that? Okay, so we're going to get a little deeper into word problems here now, and we're going to add in a couple of things. Okay, so first off, we've always been given navigation angles in one of two forms. Okay? The first form would be just a straight up bearing of 170 degrees. Okay? If that's my bearing, then I go from 0 to 90 to 180 to 270 and back to 360. So 170 would be down here, and that would be my 170 degree angle. Okay? The other form that we haven't been given it so far would be, in this case, I'll do the same angle, south 10 degrees east. Okay? And then you go from the south, you go 10 degrees to the east, and we get that. Okay? So it puts at the same thing. Now, so we're going to have navigation problems with that, and we've been doing this a lot already, but the first thing that we have to do is we have to convert it to a trig angle. Okay. What would this 170 degree bearing or south 10 degrees east be in a trig angle? Anybody? Trig angle for this one? 280 degrees. Okay? Because trig angles start at 0 there. So trig would be 0, 90, 180, 270. So then that would be a trig angle here of 280 degrees. And then that's how we're going to use that in that problem. For the rest of the problem, we're going to use it as a trig angle. What we're going to add now is, very last thing you're going to do is you need to convert it back to your original angle form. Meaning, so if you were given the bearing, the blue bearing angle, you would have to convert your trig angle at the very end back into a bearing angle. If you're given south 10 degrees east, at the very end, you're going to have to convert it back into north-south, some angle east-west. Okay? All of those that we are using today, or what we're going to add in today is what I should say. Sorry about that. So what we're going to add in today is we're going to add in the wind factor. Okay? So if I am a pilot, or current if we're navigating on the ocean or something like that. If I am a pilot and I am aiming for the black chair in the back, okay? So I set my speed, I set my course, okay? So I'm flying along. If there's no wind, I'm going to fly right to that black chair. Okay? But if there's a wind, okay? Let's say the wind is coming from this side of the room going to that side of the room. As I set off, as my plane is flying, suddenly now I'm going to end up way over here. I'm going to end up off course because I didn't make any adjustments. Okay? So that's what we're going to bring into play today, is we're going to bring in the wind and the current. And we're going to use vectors to bring that in. And so what we use is we use a simple equation, vector A plus vector W is equal to vector G. Okay? Vector A is going to be your vessel. Okay? So that could be your plane, your boat, whatever. Okay? Your hot air balloon, whatever you want to call it. Okay? That's your vessel. That's what you're traveling in. You set that speed, you set that direction. W is going to be your wind or your current. Speed and direction. Okay? You got to get a vector for your plane and a vector for your wind and your current. And G is going to be your true ground vector. Okay? So that's what you're actually doing. Okay? A is what you, kind of like when you set the cruise control in your car. Okay? A is setting the cruise control on your vessel. Then you're getting acted upon by the wind or the current. And G is what's you're actually happening. If the wind is from behind you or if the current is from behind you, it's going to help you. It's going to make you go a little faster. Okay? If it's coming at you, you're going to go a little slower. And so on and so forth. Okay? Words are important. Okay? So especially when you're reading these problems, you got to kind of read them a couple of times to make sure you decipher what you have. Okay? All right? Everybody good on A plus W equals G? All right. Here we go. A plane has an airspeed of 450 miles per hour on a bearing of 150 degrees. The wind is blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? Okay? So we're looking for true course and ground speed, so that's going to be vector G. We're looking for vector G. So my plane has an airspeed of 450 miles per hour and a bearing of 50 degrees. That's going to be my A. So a bearing of 150 degrees would be down here, where this angle right here is 150 degrees. First thing that we need to do is we need to convert that to a trig angle. Well, my trig angle is going to start here and come all the way around to there. What would my trig angle be? Not 330. Not 290. 300. Because this angle in here is 60. This angle down here is 30. So my true trig angle would be 300 degrees. Okay? So vector A then would be the vector 450 cosine of 300, 450 sine of 300. Agree with me on that? Okay. Let's put those in the calculator. New problem, so I like to just start fresh. So I'm going to start a new document, but that's just me. Okay. Crazy like that. Okay. 450 cosine of 300. I'm going to store as my A. 450 sines of 300 I'm going to store as my B. $225, $389, $711. Make sure I got that right. $389, $711. Yep. With me on that so far? Okay. Now we've got the wind blowing with a bearing of 60 degrees at a velocity of 50 miles per hour. So that's going to be vector W, bearing of 60 degrees. First thing we need to do is we need to convert that to a trig angle. What would my trig angle be for this one? 30 degrees. Okay. So vector W (50) cosine of 30. I'm storing as H. 50 sine of 30. I'm storing as I. 43,313. Agree with me on both of those. Okay. A plus W is G, so I'm going to add those two together to get my vector G. A plus H, I'm going to store as X. B plus I, I'm going to store as Y. 268 .30127 and negative 364.71143. Yep. With me? Okay. So now the speed of the wind is going to be the magnitude of G. So I get the speed, the true speed of the plane is 452.76926. Vector G is in quadrant number 4, so I'm going to have to use a reference angle. Now when I go to type this one in, because my y is negative, to clear that negative, I'm going to type this in on the calculator as inverse tangent of negative y divided by x. That will then clear that negative sign for me and give me an acute angle of 53.65981. But now here I've got to convert that back into a bearing angle. So I am in quadrant number 4. So I'm down here. I just found my reference angle there because it comes off of the horizontal. So that's my trig reference angle. My bearing angle is going to be this angle here. So I need to add 90 to the reference angle. If I add 90 to the reference angle, then that's going to be 143.65981 degrees. So the plane is really traveling, the true ground speed of the plane is 452.769 miles per hour, and it's traveling at a bearing of 143.660 degrees. Agree? Questions, comments, concerns, clarifications? Think you're ready to try one on your own? Yeah? Go for it. Try this one. A plane is flying with a bearing of 300 degrees with a velocity of 500 miles per hour. Because of the wind, the plane has a resultant velocity of 525 miles per hour and a bearing of 305 degrees. Find the velocity and the bearing of the wind. So we got a plane. That's going to be my A value. Oops, that breaks this way. Plane flying with a bearing of 300 degrees, velocity of 500 miles per hour. So that's going to be my A. So a bearing of 300 degrees is going to be way over here, where this is 300, which would then make my trig angle here be 150 degrees. Do we all agree with that? So that vector A then would be 500 cosine of 150, 500 sine of 150. Get a new one going here. New calculator. 500 cosine of 150. 433, and then 500 sine of 150. 250. 433. Oh. Come on. Don't quit on me now. Get me scared there for a minute. Now I lost it. 433. 013. Okay. Then it told me that I had a resultant velocity of 525 and a bearing of 305. That's going to be G. Okay. So my bearing there is 305. So this right here would be 305 degrees, which means then that this angle here is going to be 145 degrees. So that's going to be vector G then is going to be 525 cosine of 145, 525 sine of 145. $525 cosine 145. Oh, forgot the H. Negative 430. $301, $128. Okay. A plus W is equal to G. Which means then that W would be equal to G minus A. So I'm going to subtract the G value from the A value, or the A value from the G value. So I'm going to go H minus A is going to be my new X, and I minus B is going to be my new Y. So that's going to give me the vector 2.9, oops, I forgot a 5 in there, 95788 and 51.12763. Now I need to find the magnitude of W. $51.21312. Then I need to find, I can go directly, this is a quadrant 1 vector, so I can go directly to W's direction angle. gets me 86.68897 degrees. Okay. This is a quadrant 1 reference angle. So that means then that that angle is here. I'm going to change this just for the notes. I'm going to change this to a reference angle just because. Then we can see it there. But I need, for my answer, I need this angle right there. That's the angle that I need. So that angle is going to be 90 minus the reference angle that I just found. So 90 minus my answer is going to be 3.31103. So the wind is blowing at 51.213 miles per hour at a bearing of 3.311 degrees. Questions, comments, concerns, clarification?